Hello, everyone. Hopefully this is working. Uh, what's up? Eyal here. Oh, this angle of the camera is very disorienting. I guess this is a center of sorts. All right. So I thought after this discussion came up quite often in our Discord group, the Audio Programmer Discord. We keep getting questions about doing tempo sync stuff and how to sync with the BPM. And just the other day, I had to do it. I had to write something like this, and I realized I haven't done it in a few months. So maybe it would be a good chance to do it with you all online. Maybe we'll learn something. Maybe we'll have an interesting discussion. Maybe I'll have a good example to post on GitHub so people can use, which would be a good reference for me. So let's see. First of all, let's see that we're doing good. Stream, etc. should be running. Hopefully the audio is okay. Hopefully people can hear me. And let's see that I can check out questions on YouTube or Facebook, wherever you're watching this. So let's go. So what's the problem here? I have I'm developing all these audio plugins. Sometimes they're effects, sometimes they're synthesizers or samplers or all kinds of musical things that they do. And many times we want to do something that's musically in sync, like quarter notes, half notes, triplets. We want to do something that's that actually has musical value beyond just like absolute time values, right? That's true for stuff like LFOs. It's true for stuff like arpeggiators, metronomes of sorts. Like we there's a lot of things we do in the software that has to be in musical time, right? Sequencers and all that. So and apparently when you go to code those. It's not always as obvious as you'd think, because a plugin, as some of you programmers know, a plugin processes things in like buffers, right? There's like if you get 1 second of audio, usually we don't wait 1 full second to get the, to get all the audio that's going to come in, all the MIDI that's going to come in this second, because that will be laggy, right? If we play live and we start to we hit notes and then the sound will come out a second later, we're not going to feel so happy about it, right? It's not going to be very musical. So audio processing is done in like really small chunks of time, like really fractions of a second, which is what you know as the buffer size in your DAW or production software. And it's sometimes not so obvious on how you take this small chunk of time and put something in it in a context that's like quarter note, half note, BPM change or whatever. Like how do you even correlate the two and make them work? So there is a way, or a few ways, and I'll show one. Hopefully we'll get a good demo project running and actually play some sounds. All right, so here's what I'm going to do. First of all, I'm going to just start a demo project. So what I'm going to do, I'm going to open, let's do this thing where I can share my screen, or maybe I can do even this. All right, so I'm going to go to my GitHub page. And I have a public repo that I'm using. It's called JUCE CMake repo prototype. This is a prototype I'm always using to start new projects, do configurations, and I'm going to use this as a template. So that's pretty much why it's made. It's made for like a good starting point that's well configured. So let's start this. Let's use this template. I'll start a new repository, make it public. Let's call it something like JUCE musical time, or let's call it just JUCE examples, I guess, because who knows what I'm going to put in there. Useful examples for the JUCE framework. And let's put this public. Let's create it. So I got myself a repo. It's going to take a second to generate. Have a cup of water or a bottle of water. Awesome. So let's start by, let's clone this, right? So now I have a repo with this initial thing, all the crap that I already put in there. And let's clone it. I'm going to go to CLion, which is my IDE. And I'm going to get from VCS, and I'll put here the address. Let's put it somewhere else, just because I like everything to be in the code directory. I'm going to clone it. Okay, so it already gave me like a nice default. It should do stuff now, like configuring the compiler, get the dependencies like JUCE from GitHub. And then it's going to set up all these like example projects that are there. Okay, building JUCE, that's a dependency of JUCE. This keeps happening, so let's give it a second. JUCE 8 is like an internal JUCE tool that does all kinds of configuration or internal configuration, but it actually has to build. Like when we configure the project, it actually launches a C++ compiler and builds it and runs it and generates a bunch of stuff. So good, I have it. And now I'm at the beginning, I want to have all these like, template projects in there, which I don't want to have. So let's start by just removing those. So I'm going to go to my cmakelist.txt, and instead of adding adding all those examples, right? I'm actually going to just, what I'm going to do for now, I'll just comment these out. So I won't add any projects. I will add the modules because they have some shared stuff I might want to use. And let me yeah, you know what? Let's add the plugins folder, right? Because maybe there's something useful in there. So let's add it. Instead, I'm just going to create a new plugin there. And then later I'll erase all the examples, but I'm sure that I got everything working. So let's start by doing this. Let's start by, let's add something called musical time example. Or no, tempo sync. Tempo sync. Let's call it tempo sync, right? It's a plugin. It's called tempo sync. And to create it, I'm going to grab this thing called minimal plugin templates. That's already there. I'm literally going to copy paste this over here. And I will change a few things. So by company name, it's going to be me, not company name. I'm doing all these changes in the CMake file, by the way. Let's call this thing tempo sync. Boop. Tempo sync. This is tempo sync. Let's call it tempo sync with a space. Plugin formats, I think that's fine. Let's give it another manufacturer code, like how about something like EA DM or something. Eyal Amir demos. Plugin code, let's call it something like tempo sync. Is synth false? That's fine. MIDI input true, whatever. Output false. MIDI effect false. All of this looks fine. And it adds some sources. Links itself with some modules. Some of our JUCE, and there's this one shared plugin helpers that's from here, from this template. And I think that's good. Now I'm going to go to the CMake list of this folder just so that I won't build any of the other ones. So I'm just going to comment these out for now. And I'll just add subdirectory tempo sync. Now I'm going to go to here, cmake reload cache, because we need to regenerate this project with new settings. And everything seems to work. And for a start, I'm just going to build a standalone version, see that I get a working plugin. Just to see that I haven't like done any configuration weirdness. Okay, built, and I'm going to run the standalone thing. That's the standalone editor for this. Has nothing, but that's okay. So let's have a look at this processor. So this is copied from the minimal plugin thing. It has, let's go to the header. So it has, let's remove my, hopefully it's going to be seen. I don't know. Hopefully people in the comments can tell me if this is shown correctly. So, so this is, this minimal plugin thing is using something I made that's in the public repo called Audio Processor Base. And this is just a boilerplate thing that overrides all the different virtual functions that JUCE offers, but so that my client plugin will not have to overload that much stuff. So the client plugin can just override stuff like prepare to play, process block, create their GUI, and get set state information. So this is just to save me some of the hassle of looking at a million functions that I'm probably not going to use. So this is useful stuff. So when we get the plugin, it's still called minimal audio plugin. So maybe I'll refactor this to something like tempo sync plugin. Let's have CLAN refactor all the class names and such. And it changed it into CPP as well. So I'm good. And most of these functions don't do much, but this process block function has some like clear all samples thing that I've done just as an example, but I'm not going to do it for now. Let's just get this out of the way so that it's empty. And just have this ignore unused thing to avoid warnings, and that's it, right? This is pretty much my plugin. It doesn't do anything. The editor, this template editor, it's still called minimal plugin editor. Let's call this tempo sync editor. It's a different name. Great. So this is right now it just loads a generic editor thing that will show the parameters. This will come in handy pretty soon. So let's try to explain what can we do to make something sync with like the host. The host is like, Ableton Live, Cubase, Logic, whatever. So there's something in the plugin API or in the audio processor API that reports these. So the host actually gives us a lot of that information during the process block. So we get a block of like a few samples to process, and the host is actually trying to keep us, as a plugin, try to keep us updated. So the host is actually sending us some of that information that it knows about, so we can sync our processing. So let's see how that looks. So if we go to the plugin processor, before I do that, let me just do a commit here. Just have some initial commit, added tempo sync project, something that so that I'll have my information or my updates stored. Let's do that. Let's push this to the repo. Great. Now, so during the process block, we can use something called JUCE. Sorry, not JUCE. This is a member function. So I can do something like get playhead. So this function gives me an up-to-date pointer to a playhead that was given from the host. So this is pretty much how we use it. So we do something like if o2 playhead equals get playhead. And we have to check this because in some hosts, like standalone hosts and stuff, this might be null, like this might not exist. So we have to be prepared for situations where hosts do not give us this. Next thing to do is do something like, so we can use this playhead with a function called getCurrentPositionInfo. And this function asks for an object called currentPositionInfo by reference. And it's going to fill it out with the most up-to-date information. So for a start, let's do something like JUCE audio playhead currentPositionInfo, and then we're just going to put this in, and this will fill it for us every block. So this is a good start. Like we can use this to use this information. We're just going to look in a bit what this info has. So let's look at this thing, currentPositionInfo. This is a struct, like a public field struct, and it's got a bunch of stuff that we'll probably see as familiar, like BPM, tempo, time signature, numerator, and denumerator. So like this, if this is like 4/4, it's 4 and 4, or 3 and 4, etc. Time in samples is where we are in samples, time in seconds. And we also have this thing called PPQ position, which is essentially musical time. Like it's essentially the time as it's counted in quarter notes. And there's other stuff here. I guess stuff like is playing. That's actually really important. Are we in play mode or stop mode? Is recording, loop start, loop end. So there's a bunch of stuff here to let us know what's up with the host. So for a start, let's print it out on the screen so we can see it. So I'm going to go to the editor, and I'm going to create some visual component that has to display that information for me. So I'm just going to do something like, let's do something called struct. I'm going to call this, okay, so maybe I should talk about this before I do it. So when we read stuff from the processor into the GUI, into the editor, we can't just read information directly, especially information that gets written during the process block, like the position. We have to use some thread sync mechanism because the GUI and the processor are running in different threads. So we can't just go ahead and poke into variables that are shared with the processing side and the GUI side. So what we do if we had to write something during the processing is we have to use things that are designed to be shared between threads. So in this case, I'm going to use an atomic. So what I'm going to do is I'm going to build this thing called atomic label. And this is going to inherit from JUCE component. And this will have in it something like a JUCE label, which I will use to put stuff on the screen. But it will also have something like a atomic double. Double is because the position, as we've seen before, is reported using doubles, right? Like all this PPQ stuff, it's all doubles. So I'm going to use the same thing by using an atomic double reference to value. And then I need a way to read this value into the label. So to do this, I'm going to use polling, right? Because I don't want to go have the processor go and call functions on this GUI component directly. So I'm just going to inherit from JUCE timer. And I'm going to click Control O. It's going to give me options of functions to implement. I'm going to go to timer and pick timer callback. Generate this for me. And in the timer callback, I'm going to go to the label and set the text with the string of the value, or JUCE string of the value load. And I don't need to send a notification for anybody. I do need two other things for this to work. So I'm going to have a constructor that asks for this value. So value to use, in the constructor, I also need to add this label. So add and make visible label. This will add it to the screen. And one last thing is I need to override the resized method. So I need to give it some size. So let's make the label set bounds, get local bounds. So that will make the label the same size as this. And for this timer to run, I actually need to give it some time, so or frequency. So start timer hertz, and let's do this in 60 hertz. So I'm gonna, in 60 frames per second, or 60 times per second, I'm going to launch this callback where I poke at this atomic value and load the number that was stored there into it. So now we have to find some way to kind of move this this real-time value into the GUI so we can see it on screen and see what's up. So I'm going to go to my plugin processor, and I'm going to define the same atomic we just defined there as a reference. So this will be the original. This will be like something like current position. Initialize it with a 0. And then during the process block, if we got a playhead and everything worked out, I'm going to do current position, store info, PPQ position. So I'm atomically storing this value. This is value that was given to me in this block, so it's safe to read from here. But I have to write it into this shared memory thing, the atomic. So I write it there, and in the editor, I just have to connect this whole thing together. So let's comment out this generic, or let's remove this generic editor. I'm not using it for now. Instead, I'm going to have my atomic label in here. Let's call it something like position label. And I'm going to initialize it with processor to use dot current position. Great. And I'm going to give it and make visible. And I'm going to position it like this, so it will get the full size of the editor. I think I'm doing okay. And let's see. Now I'm going to build a VST3 version of the plugin. And let's see if what I did made sense. Building. Great. And let me launch a host. So in this case, I'm going to use Reaper. So in CLion, I can go and attach to an executable of a host. So I can pick, Logic, Ableton Live, etc. I'm going to pick Reaper. And let's launch it. Okay, so here's Reaper. I'm going to add a new track, search for my amazing plugin. Something around like Tempo Sync. Here it is, Tempo Sync by me. And you see this little number here, right? So let me just click play, click space in Reaper. Here you go. This runs, right? So let's look at the Reaper playhead. So you see this runs exactly in sync. If I'm going to stop, it's going to go back to 0. Even if I move to like random places, like here, this is the 8th beat, right? Because it's the second bar, and this would be 12. And it really responds to what I'm doing, right? So that means that we got a good report, that the host reported what we wanted, and we can now do something according to this information, right? So this is really useful. The fact that we can just go here, see if the processor is playing, see where it is, see if a loop happened. That's also useful. So now we've made like the basic mechanism, right? We have something basic. It has, it has something on the screen. It has this like mechanic to pull the playhead from the processor. And let's do something more interesting with it. But before I'll do something more interesting, let me close Reaper. And let me commit these changes. So let's do something like added basic polling or tempo sync, added basic playhead polling to the processor, and simple GUI label to debug. All right. So now let's do more interesting stuff. So now we know the playhead, but there's actually some, oh, I realized that I was not sharing the screen while I was doing this. Anyway, I was just doing a commit, so nothing interesting happened. And let's talk about what's needed now. So we want to do, and I'm going to start by doing something that plays some audio. Like in this case, I'm probably going to use white noise because it's the simplest. And I want to do something that plays that audio or this white noise, but plays it in like a musical time, like quarter notes or eighth notes. And I want to hear it sync to the host. So for example, I want that if the song changes tempo, it's going to be synced back in it. So let's see how we can do something like that. So this actually is more complicated than just this. So this is like, this gives us information that's only true for the start of the block. So the block can be, a number of samples, right? And a block can have, 64 samples, 128 samples, 1,024 samples. It can have quite a lot of samples. And this is only accurate for one of these samples, for the first one. So we want to be really accurate, right? We don't want to have our code just skip samples and, being almost exactly in time. We want to have it perfectly in time. So let's see how we can do this. So for a start, I'm going to not do this because this was something I just did to check the mechanism, right? So I'm going to remove a little bit of that mechanism, and I'm going to write something better. So what I'll do, I'm going to write a class called transport. And this will be something like, let's include some headers that I have here. So let's just include the same header. So I'll have all the JUCE code stuff. And let me make something like struct transport. Let's include it in the processor so CLion knows it exists. Great. So what this class is going to do, it's actually going to do all the calculations so that we know where the transport is every sample and not just in the beginning of the block. However, on the tempo, because usually it's reused by a bunch of other processing functions. Like if you have two LFOs that both are in sync, then you need to pass this information to both of them. So I like to store this information in something that's stateful, like a class or a struct. So hopefully the quality is okay. This kind of looks weird on my monitor, but hopefully it's fine. Okay, so I'm going to store it in something stateful. So what I'm going to do, I'm going to store this as a vector of double. Let's call it like PPQ positions. And this will store the position in a vector of the position in every sample, so that we can just later read from that. Okay, so here's how we do this. We need a few functions to communicate with our processor. The first one would be prepare, right? Prepare is similar to what we know from prepare to play, usually called from prepare to play as well. And we need this to allocate, and allocate memory. So this usually asks for double sample rate or something, and int max block size. And so the first thing we're going to do is we're going to resize PPQ positions to be on the maximum block size. And this actually gives me a yellow warning here, and we're going to talk about this warning and how to deal with it in a bit. For now, let's acknowledge the existence of this warning until we fix it. But it's fine. So I'm just going to resize PPQ positions to be. You know what? This is distracting. I hate warnings. We're going to deal with the warnings. So I'm just going to do something pretty evil. I'm going to remove in the CMake the JUCE warning flag. So I'll use a lower version of warnings. You should not do this. You should usually deal with that warning correctly. And we will do that. So I just don't want to spend time on this while I'm on the flow of doing tempo sync stuff. All right. So I'm getting told in the comments that this was freezed, but hopefully it's better now. Please report to me in the comments if this is okay. Okay. So we are, on the prepare, we're going to resize this to have the maximum block size. This is to avoid memory allocations during the process call. And now we're going to run a process call. And process would need a few things. So it would need that audio playhead that we talked about, which is potentially valid. That's why it's a raw pointer. And we need to know how many samples we have. So something like int num samples. And let's see what we need. So first of all, we need to check if playhead is null. So we first of all need to validate this because this could be null. This is a valid scenario. And now let's go back to the processor. We need something like this, right, to get the position. We're just going to grab these two lines, put them in here. But instead of just using this like this, I'm going to store this info now as a stateful object because even though it probably doesn't cost a lot, I don't want to call the constructor of this every time. I'm good with just keeping it here in the function. And there's also some other advantages to having it persistent as a class member. So we got this. And so if the playhead is valid, I'm going to store it inside the position info. Now we're going to do the interesting part. So we need to for loop over the samples. And we need to calculate the timing, the musical timing over each sample in here. So how do we do that, right? Let's do some theory in a second, right? So we have information like the tempo. We know where we are at the start of the block. We need to know where we are in the middle of the block, right? So we might get a buffer of 100 samples. What does it mean to be in sample number 50 in terms of music, right? Not in terms of like absolute time. So to do this, we can use the information that we have to do a calculation. So the first thing we need to do is we need to figure out how much musical time happens every sample. And that's not something the host gives us, but we can deduce it from the information in the host. So we need something called, I'm going to call it something like, I don't even know this yet. So I need something like PPQ per sample. That's what I need, right? PPQ per sample. How do I know the PPQ per sample? Let's see what I have in my current position info structure. So I have the BPM. BPM is how many beats per minute, right? It's not per second, but obviously we can assume this. And we know the PPQ time at the start. We also know from the prepare call, we know the sample rate, right? So we can also learn a few things from that era because we can be at 4400 or we can be in 96 kilohertz or any other number like this. So what we can do is we can, so essentially if the sample rate, let's imagine this was, 44,100, right? A very standard sample rate. So the time, or the linear time, like the time per second, would be 1 divided by the sample rate, right? That's the time per second. So let's store this information, because I'm not going to, this sample rate thing is not going to stick around. So let's store the result of this. So I'm going to store something here called double time per second. Initialize with 0. So time per second is 1, right? Because if the sample rate is 44,100 is 1 second exactly. So this is how we calculate this. Now we need to calculate something based on the tempo, because the tempo will make it different. So if we're in 120 BPM, the musical time will move faster, right, than in 100 BPM or 60 BPM. So we need to calculate the musical time based on the tempo. So now we know this time per second. We can do so I want to know this, right? Double PPQ per sample. So PPQ per sample, let's give it a function so that so something like get PPQ per sample. It's nice. So we start with time per second, and we know how many beats we have per minute, which is BPM, beats per minute. So let's find out how many beats we have per second. So let's call it beats per second equals info.bpm divided by 60. So this will give us how many beats in a double are in a second. And now when we have this, all we have to do look at that. So yeah, so all we have to do, I think, right, is multiply this by this. I think, right? Time per, oh, sorry, this is not time per second. This is time per sample. I'm blanking out here. This is time per sample. Great. So this, and all we have to do now is, I think, if I got this correctly, and I'm not just blacking out because I'm not thinking about this, but I think all we have to do is multiply this return. Oh, here we go. So I get question from George here if I'm going to have the video stay up. Sure, yeah, I'm going to have it stay up unless I do something embarrassing. Hopefully I won't. Right, so this will be beats per second, time multiplied by time per sample. Am I correct? Oh, sorry, I'm blacking out of this. This is where it's always good to look at my notes, right? Always blacking out on this stuff. Oh, sorry, 60 divided by BPM. I'm out of this. 6 divided by this, and then 1 divided by the other one. So so this is right, 60 divided by info.bpm. And then, right? I hate to do math in front of other people. It's very, very, very stressful to get this wrong while I'm thinking about talking, right? So, right. Oh, so I did something else there. What I did was I actually did. Oh, so I did this differently, right? So I did something like this. So what I did was I did samples in minutes, right? That, I guess that makes more sense. So let's do samples in minutes. And this, and I'll calculate this by doing sample rate times 60. Yeah, I think that's better, right? And then what I did there, samples minute divided by BPM. So let's just copy this. I'm so bad at this. Here you go. You'll see all this other crap I'm doing later. Good thing I made some notes. Here you go. And I'm just going to return this. So I think this will work, right? So this is, after me just having a blank out there for a second, this will be const. So this, this has, now I have the samples in minutes. I'm dividing it by the beats per minute, right? So, and then I just have 1 divided by that. That should give me exactly how much musical time is in 1 sample. Great. So now I can do something like O to PPQ per sample equals. And I'm going to store this because I'm going to reuse this this variable. And now all I have to do at every sample is go to what do you call this, PPQ positions, and this equals to info dot PPQ position. So where we started essentially. Sorry, at sample equals to this plus oh, I need to do something else. So I need to actually do this in relative. So what I probably need to do is, yeah, so PPQ per sample, and let's store something else called like double offset, and then so we start with the same one, so plus offsets. The first one will be the same one, so 0. But then starting from sample number 2, we're going to do offset plus equals PPQ per sample. So I think this is pretty correct. So this will give us the timing per each sample. And it's going to write it down into this PPQ positions vector. Great. So let's see if we can do something interesting with that. Let's make it play sound after we've done all these calculations. Oh, yeah, I think that's okay. So let's start. First of all, this atomic current position now is not going to be up to date because it's not using our transport class. So I'm just going to move this atomic thing right here. And I'm just going to do that. I'm just going to store the latest thing now that we've finished. So this is going to be equals to store this. So I'm just going to store this when we finish the block so that we can read it from the GUI. So let's make sure the editor is connected. We're probably going to have a bug now because the editor cannot find this variable. So I'm going to go to the processor and have my transport class in here. In the GUI, I'm just going to pass it in the editor. I'm just going to pass it instead of current position. It's going to be something like transport current position. And in my processor, I have to do 2 things. So I can remove this stuff. And I just have to make sure I'm forwarding the prepare and process calls because those will have to be up to date when the sample rate changes. So first of all, I have to do transport. Oh, transpot. I need to go transport. That's better. So transport prepare, sample rate and samples per block. And during the process, I'm just going to do transport process with get playhead and buffer get num samples. Okay. First of all, I'm just going to build the same thing, see that I did not forget anything, that it worked, and then we're going to do something that plays a sound. If there's any questions, by the way, feel free to ask it in the chat. Okay. So let's start by doing, okay, this builds. Let's see that it runs, right? Let's run Reaper. And let's see that it loaded, continued loading the same thing. Track, add track. Tempo sync. All right, so this still works. And by the way, this has a slight offset because now it loads the timing at the end of the block instead of the timing for the start of the block, and we're gonna fix it in a second. So, but this is okay. It still kind of works. So let's start by making something that plays sound in response to this. So in this repo, this example repo, I already have a little white noise thing. It's under modules, shared processing code. I have this little white noise oscillator, which just gives you a random sample. So let's add that. So I'm gonna go and add shared processing code into the list of modules. And then I'm gonna have this include, so include share the processing code, and let's have this thing. So this is called white noise oscillator noise. The oscillator, and then we just have to forward the call in the process call. So first off, let's just see that it plays something, so we get some sound. I'm just gonna do noise process buffer. Yeah, it might be super loud, so I'm just gonna do noise apply, buffer, apply gain, and give it some low number because this might kill the speakers. So let's hope this is not too bad. So let's load the plugin. Starting to sweat. It's so hot in here. Okay. So we got it going, and then let's launch Reaper. Here you go. So insert new track, load the plugin, tempo sync. Okay, so this amazing plugin now plays white noise. It's pretty awful sounding. I hope it was not too horrible on your ears. I'm gonna make this even softer because it might be like really loud. We just need to make sure that some sound is happening. Okay, need to my glasses. Okay, so we got a processing happening, and now we want to play this and use the transport and have this play in sync, right? So let's do this interesting bit. So I'm going to do a sample by sample loop. So for buffer number of samples plus samples. So this is a loop that does everything per sample. And if, oh, here we go. And we want to make sure that if, let's decide that we want to just use a tempo of quarter notes, right? So now we know this thing because we have this transport.ppq positions. We know this will actually give me the right timing in this exact sample. So let's do something like this. Let's do that if this if f mod this and 1, or let's call this, let's do something like relative position. So this will be the relative position of this musical time, right? So this will mean if I do this, this will give me this will give me a modulo of the right position, and it will keep returning. So it will instead of whenever it reaches 1.0, or it's not going to go up to 2.0, it's going to go back to 0. So this will give me a loop. Essentially, it's going to give me a loop of one quarter note. So with this loop, we can use to decide if you want to play this thing or not. So we can do stuff like if the relative position is smaller than, let's say, let's give this 1.0 because we're in doubles. If it's smaller than 0.5, I'm going to explain why 0.5 in a second. Then we want the white noise to process. So if it does this, let's do something like a float sample. Sample value equals 0. So the default, if we don't have to play anything, we just give it a silence. If we do want to play something, so if we're below 0.5, and by the way, the reason why it's 0.5 and not 1, and not just one full quarter, is we also want to hear the note stopping. If we just play continuously, we're not going to hear, or not going to be able to notice the musical thing that happened. Like we actually need to stop after an 8 notes or something so that we hear the quarter notes being played. So if the relative position is less than 8 notes, then sample val equals noise get next sample. So after we've positioned this, all we have to do is do a channel loop, so that because we might have a stereo signal or something, so a channel equals 0, channel smaller than buffer get num channels, and then buffer set sample channel sample val. So I think this is essentially what we need. Let's hope I didn't mess up something, but I think this is it, because we know the relative position in terms of like loops of quarter notes. So this is going to tell us that the time in a quarter note that we are in. If we're in the beginning of the quarter note, we're going to ask the noise for the next sample. If we're not, we're going to just use the 0, right? That's essentially what it is. So let's bring it on. Let's launch this thing. Okay, we launched it, and hopefully what I did now will not blow up my speakers. So let's launch Reaper and see what's going to happen. Reaper goes up, add new track, and we call this thing tempo sync. Keeps playing continuously because we haven't handled stop mode yet, but let's run it. Oh, it doesn't work. So I messed up. Let's see exactly when I messed up. If the relative position is equal to is smaller than 0.5, so let's see what I screwed up there. Oh, okay, so I think I screwed up in the transport thing. So I think that's what happened. In the transport, I'm taking the PPQ position. I'm adding the offsets. Let's see what I screwed up there. Taking the initial position and doing this. Storing it. What did I miss there? Something probably pretty silly. Blah, 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 blah. PPQ positions, sample equals, so what did I forget out in there? Want this? Let's see what we got. What kind of values we got here? Oh, and just to make sure, I probably need to also do something like handle playing and not playing, because if we're static, let's fix that first. So let's do something that if we're not playing, so here in the plugin processor, if so if transport.info.is playing and this, so if we're not playing, just don't play anything. Then we're going to see exactly what I did wrong. Track, tempo sync. Let's see what's happening here. Relative position. So we keep getting stuff. Are we ever going to get to like 0? I wonder. I don't know. Let's add this thing of if sample val equals to 0. Okay, so we don't get to 0. Looks like this is always below 0.5. Let's see why. So we're always getting like too small of a numbers here. That means we never, the host never gives us something below 0.5, or this never does. Let's see why. This transport PPQ positions. Blah, blah. So we never get. Why is that? I probably screwed up something in the transport that I wasn't noticing. Let's try it again. Transport process. Buffer.getNum samples. I'm adding to the offset here. Right? Let's think about what I screwed up there. Probably something very super obvious. Let's take a look at my my demo code there for a second. Use the multiply instead of add. Should be fine. Sample plus PP. What did I miss in there? Something obvious, something obvious. PPQ per sample. I think it should be the same, right? So what's going on here? Why am I not getting what I should have gotten before? Can we transport string instead of transport? Well, if it was transport, it probably wouldn't compile. So I use a refactoring tool. So compilation error could definitely be the problem, but the compiler would warn us or stop us from running the program. So I don't think it's a typo in this case. Fortunately, this isn't JavaScript, so the compiler has strong sensitivity to spellings. But it's probably something obvious like that I just didn't notice because I'm writing code live. Blah 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 blah. Right, seems to be going up. So it looks like, for some reason, The info that it's given me is never above 0.5. Why is that happening? Like, it wasn't happening in my older experiment that I did earlier, just to check that I still know what to do. Because this looks fine. Maybe I'm blanking out on something. Buffer, get some samples. Maybe someone can notice the obvious thing I'm missing. What is that obvious thing I might be missing here? That's what this will give me the right thing, right? Relative position is transport, blah 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 blah. Let's see, because one of these in the transport itself, one of these at some point, PPQ position, blah 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 blah. So add PPQ per sample, that's okay. Because at some point, I'm gonna see if the numbers here are wrong or the numbers that are in the processor are wrong, right? So this gives me, right, something 0.1. Here you go, 0.7, blah blah blah. So the F1 thing should now give me the modulo of this thing in a correct way, right? Yeah, because that's scored correctly. That should be like whatever, 11.73. Yeah, so Sysmic is saying the correct, but it does seem like the position given to us by the host is fine. But it looks like I screwed up this something in here that prevented this from happening, or working exactly. So looks like, what did I screw up here? Because I did ask it for this sample, and I did position on 1.0. Oh, here we go. It does give us something above that. Yeah, it does work. I'm just I have no idea why it didn't work. Yeah. Okay, so we are definitely hitting. I just did a bug with the debugging, so we definitely get the right thing. But what else did I do? Set sample. I did this correctly, I think. Oh, here we go. Silliest thing. I just did the full buffer processing. I think my code was totally correct. So sorry about this. Okay. So the problem was I overrode everything that we just did here with the test noise I've had before. So silly mistake. I was not expecting this to happen, but here you go. It's always the things you don't expect. Okay, this should work now. Let's bring up this track. Tempo sync. Here we go. So we stop and there's nothing, right? And when I play, right? Let's do more interesting things. So let's change the tempo. Let's write down 80. So this is the Reaper click, right? So this is perfectly in sync. Let's make this 160. We're dancing here. Awesome. Let's record the result of this to see if we were accurate. So let's do inputs, record outputs. Let's record the output of this thing. I'm going to click record. Oh, not this stereo, but record multi-channel. I think that's the one. Forgot how you record the track back to itself in Reaper. Anybody can remind me. Input. I'm looking out. There's some way to do this, right? Maybe it's one of these options. Chord input stereo. There should be something like this. No. Input. Latency compensated. Not this one. There's one of the options here should do this. Just blacking out on my Reaper settings here. Let's see. Record. Output. Oh no, I don't remember. Anyway, you can hear that it kind of works. If we had recorded, you know what? Let me just open this in Cubase where I know what to do. Yeah, let's do that. Let's open in Cubase. And I'm going to just flatten this out to see that I've done everything exactly in an accurate way. So let's open Cubase. It should load this plugin. Yeah, so look, people are writing to me actually how to do this in Reaper. And they're right. Like I was not crafting my Reaper skills. You know, it's one of the things when you program plugins, like every day I'm juggling between like Logic and Ableton Live and my internal host stuff and all kinds of like special things that I have to test. So I forget how to use like host except for like Cubase and Ableton that I use for my own music. So let's bring this on. Already registered. Add an audio effect. Here's my tempo sync plugin. Beautiful. Still responds to the tempo changes. And now I can do stuff like, I'm just going to add a clip here. And I think I should be able to just do render in place. Render with the channel settings. Yeah. So let's see the output audio. This is a bit weak, a bit soft. So you can see that it starts and stops, right? Let's see the start time. Let's remove this thing. Let's zoom over here. Let's zoom over here. So you can see that the start position is exactly, well, in this case, we might have gotten a 0 right on the sample, but it's pretty accurate, right? Let's go to this other one. Here you go. It's pretty damn accurate with the way it looks. So this was a very low value, then went to a lower value. These are random, so sometimes there's a number that's close to 0, but you can see this is super accurate. Like this is as accurate as you can get in timing, right? Great. So so we got this to work, and we've verified that our algorithm works. Let's do something else just for the ending. So let's do something that maybe changes the the subdivision, right? Maybe we want to do something that starts with quarter notes, but maybe we want to switch it to like 8 notes or 16 notes or whatever, like some other kind of time, so that it's dynamic, it's not static. Let's try this. So let's remove this. Get rid of this project. First of all, let me commit this change I made. So tempo sync, added synced white noise. Okay, so our beautiful noise is in sync. And what I want to do is use this so that, so for example, just like we did this with quarter note, let's do something else. So let's add a parameter. So to add a parameter, there's a few ways to do this in JUCE. I'm just going to use a very, very raw way to do this. I'm going to add an audio parameter. Let's call this, you know what? So we'll have fun. Let me create my own parameter so that will have the subdivisions in there. So let's go here and let's do struct subdivision parameter that will inherit from audio parameter choice. I'm using choice because we want to have like multiple choices that have like good names, like quarter note, eighth notes, etc. And we don't want to have like a number in there. So in the constructor, we need to initialize the base class and give it stuff like the name, so like subdivision. I think one of those. I think this is actually the parameter ID, and the second one is the name. They look the same, but sometimes the name has more things. Like the name might be subdivision of the track. Like it might have a bit a more interesting description. Then I need the choices, so it needs to have. I'm gonna add this in a second, and the other thing is the default. So the choices that it asks for is in the form of something called a string array. This is a JUCE, like a vector of strings of sorts. So it gives it this. These are the things that will also be displayed in like the GUI or the automation pane. So let's do something like get choices and return. Let's say we start with. So let's say our or maybe we want to do like quarter notes, and then, or let's even do something. Let's do like a bar, like 4/4 bar or something. 4/4 bar, half, and then quarter note, and then eighth note, and then 16th note. Here we go. So these are the choices. We'll pass them to the parent class. And here we'll need something that also the processor can use to get the musical time with this, right? So we need something like float get division PPQ. So this will give us this division that we just saw, so that we can do this calculation here, like this 1.0. This is actually a quarter note, right? 1.0 is a quarter note. So we need the equivalent in a quarter note to this. So I'll do something pretty hacky now. Usually we can do this in a cleaner way, but I'll just do like switch get index, and I'm going to say that if it's 0, give me 4. This would be probably double. So give me 4. And then case 1, which is case and not clase. Case 1, return 2. Case 2, return 2 is a quarter note, so it will be 1. And case 3, return half. This is the eighth note. And then case 4, return 25. So this is 16 notes. So this is like the raw. I don't know, return 0 if it's wrong, or 1 to give it some other default. Okay, so this is. Hey Christopher, see Christopher from Indonesia here. So that's awesome. I love that you people are asking questions and saying things. I'm happy that Stefan and all of you like are. I love that you're so engaged with this. So this is a lot of fun. Right. So these will give us a few musical options, right? And let's give. So this starts from 0. So let's give it like a quarter note as a default. This is the default thing. And I think that's okay. Now we need to add this parameter to the processor. So I can just do there's something pretty awful we must unfortunately do in JUCE, is that we have to use raw pointers for the parameters. This is really annoying. Subdivision parameter pointer equals subdivision. And usually this is considered a mistake in C++. Nowadays we want to use smart pointers and never do something like this. So this is a very edge case because of legacy reasons. So JUCE forces us to essentially in JUCE the plugin is going to take ownership of the parameters. So we must have a raw pointer so we can refer to it later. So we initialize it here, but then here at the beginning at the constructor, we do add parameter subdivision. And now when we have this pointer to the parameter, we don't need to delete it, by the way, because the processor deletes. This is a very weird flow, something that JUCE should probably change. But anyway, now all we have to do is, instead of using one, we'll do subdiv get division ppq. And here we'll have subdiv get division ppq divided by 2. To make this nicer, let's do it outside of the loop. So to subdiv equals, or let's call it current subdiv equals this. Subdiv equals this thing divided by 2, because this is, like we mentioned, this has to be the length, right? Because if this if this quarter note or whatever would be full length, we would just not hear it. It would just sound continuous. So we need the pause, right? The silence is the best note that you can play. So you go over here, and this will be the current subdiv, and this will be the half subdiv. And I think we're good. The only thing we want to do is to make sure the GUI represents or reflects this thing we're doing, so we can change it. So in the editor, now instead of using this atomic label thing, we now don't need it. We can use what was there before, which is JUCE generic processor editor or something editor. And this can just be initialized with the processor. Change the names here. And this is something JUCE gives that was going to give us a display over the parameters. Let's have a look. Got it. Let's load Cubase or Reaper. Reaper is cleaner. Let's add our plugin on a track. Oh, tempo sync. Okay, there are 8 notes, right? 40 notes. Half notes. Let's launch our click so we hear it in sync. Quarter notes. 8 notes. 16 notes. All right. This is a lot of fun. Now, because this is automated, let me get out of here and just load like something fun. So let's load like Ableton Live. Suggested that I can use this opportunity to have fun with my amazing creation of timed white noise. So I'm going to bring in, let's give it a second to load or to scan my plugins. It might take a second because I just built it. So let's ask it to do oh, here we go. It's rescanning. Here we go. We got it. By Alamir, tempo sync. Oh, I need to fix my audio settings. Audio, go out through this actual sound card, which is Babyface Pro in this case. Let's lose a low buffer. Here we go. So now I can assign this thing to a MIDI control. So I'm just going to do Command M, click this, assign it to my, oh, keyboard is not, oh, forgot to enable my keyboard. Go to MIDI settings, enable my RME as a remote. Oh, not this one. This one is a remote. Then I should be able to do, here we go. I touch my keyboard mod wheel. And now, this is going to be fun. Where's my beautiful click? Yep. Where are you? Here we go. Click. And now, I can actually jam with my mod wheel, right? Let's bring up the tempo. So this is fun already, right? Okay. So here we go. So looks good. So I think we're in a good place. I can keep going with this, but I'm getting a bit tired. I've been going on for, I don't know, how long was this? I don't know, a long time. So hopefully some of you will enjoy this. I'm going to push this now to my repo. This is now added automation control over subdivision parameter. Okay, let's push this. This will be up on my public repo on GitHub. I can probably do a little bit of cleanup now, so I can just do stuff like I can probably remove all these other plugins, like basically everything but this. So I can just remove those. Let's remove all this stuff. Let's remove all these apps because they're not in use. I can even ignore this, all this like stuff. So let's just do a simple CMake file that will just add the modules and the plugins. Remove all these if statements. I don't need the JUCE example, so I can remove this. Yeah, something like that. I don't know. Let's see if it's still okay. Hopefully this will be a clean. Oh, and there's this label thing we did there, right? There's some label in the editor. You can probably just remove this label. I probably need to. I'll move it later to one of like the shared stuff because this is so common. Like wanted to display some processor value. Well, so hopefully you enjoyed this. See. Hopefully you've enjoyed this. If someone has any questions, let me know. This should work. Let's commit like a project cleanup. Yeah, any questions, feel free to ask me in the comments or whatever. I'll try to do a few of those whenever I run into something that's interesting. I think musical timing is interesting. There's a lot of sub-problems that we have not talked about, like how to deal with sequences that are more complicated, how to deal with loops, how to move this into MIDI. Hope this was useful. Good luck to everybody who watched it. Thank you.